This file is going to focus on creating a Threadmill toolpath. Now to access thread milling, we can go over here to our toolbar and click on this icon right over here, or from your toolpath button, come down to circle paths, over and down to Threadmill. But before we get started creating a toolpath, I'd like you to take a look and see what is included with this file. I'm going to open up my Levels Manager, Alt-Z, turn on my wireframe. Currently all that's on the screen is a solid. Right-click Dynamic Rotation, pick right over here, and I can move this around. Now, in addition to the solid, you'll see a few circles, points, and a rectangle. That wireframe geometry is what was used to create the solid. And as far as creating our Threadmill toolpaths, all we really need are the points. The red circle right in over here is used in the toolpath that comes with this file. And this is a contour with a slot mill that's going to come right around this standoff and cut a thread relief before we cut our threads on it. We're going to take a look at creating both an internal Threadmill toolpath and an external Threadmill toolpath. The next thing I'd like you to look at, Alt-Z again, turn on Level 3 and all off for the rest. Now this should stay checked and highlighted yellow as long as you have this box checked. Click this off, go to Top View, Alt F1, Fit to Screen. Now what you're seeing here is my custom tool that I drew on Level 3. F9 gives me my axes indicator, X-axis, Y-axis, and what I've drawn here is an 8 threads per inch thread mill. I have 9 active teeth, and the pitch, the distance from one tooth to the next, is 1/8 of an inch. Now the way this is drawn, the bottom and center line of my tool starts at our origin, and I extended it up as high as I'd like it to be. I do not connect these two endpoints together. I leave this as an open chain. So this is a multi-tooth thread mill. Alt-Z again. I could turn on dimensions and you could see my pitch. Here's my distance for active teeth, my overall length. Alt-Z again. Now I'm going to turn on Level 5 and turn these off. And what I have here is kind of like a boring bar, but it is shaped at my 60-degree angle. This can be used in a thread mill operation, but it only has one active tooth. If you don't have an actual thread mill, you can get away with using a boring bar that you've ground into the proper shape. Now what you're also going to find when I go to create these toolpaths, I have created undefined tools and I have pointed to the levels that I've drawn this geometry on. So my tool shape definitions are coming from these drawings. So we'll do 2 sets of toolpaths, one with the 9-tooth thread mill and one set of toolpaths with the single tooth thread mill. Let's go ahead and turn our wireframe back on. I'll turn this off. Also turn our solid back on so you can see it. Alt-7 gives us our isometric view. Let's go ahead and activate our Threadmill toolpath. This opens the same dialog box as for drilling operations, where we can pick entities, which would be our circles, or we can pick points. The first thing I'd like to do is pick the top point right over here, and we'll do our external thread first. I'll say OK, and I have our first tool. What I'm going to do is enter this by right-clicking and edit the tool, and to show you what I have. Now with this tool, I have it pointing to custom level 3, so that's where the geometry for this multi-tooth thread mill is residing. I've specified the diameter so that it matches the geometry that I drew, and the value of this diameter is represented by this yellow vertical line right here. If I change this to 1 inch, look at what happens. And this is the value that Mastercam is going to be calculating the toolpath. And if it doesn't match up with your geometry that you drew, you're not going to get satisfactory results. I'll say OK. Now this is the tool that's selected. I can set my spindle speeds and feed rates. I can also come back here in the back parameters and I could specify my feed rates that I would like to see happen. Let's move on to our Threadmill page. Number of active teeth. Now in this tool we have 9 active teeth. We can set our clearance plane. Where do I want to wrap it down to? I'll leave this at 1/4 of an inch. My feed plane, this will be fine. Top of thread is at 0. My thread depth is actually from the top up here down to this bottom circle is minus 750 thousandths. Well, I'm going to be cutting a thread relief in here, so I don't want to take any chances of the tip of my tool touching the top of this surface. So I'm going to set this for minus 0.745. In this tool path, it can either be absolute or incremental. Since our point resides at 0 on the Cartesian coordinate system, the values would be the same. My thread pitch is 1/8 of an inch. Thread start angle is 0 allowance. This allows you to increase or decrease the cut of your thread. Taper angle, if you're doing pipe threads, for example. Compensation type, whether you want it in computer, control, wear, reverse wear, or off. Entry, exit, arc clearances. Do you want to start at the center? Perpendicular entry, helical entry and exit at the top of the thread, helical entry, exit at the bottom of the thread. Linearize helixes. If you have a machine that cannot execute helical moves, if you check this, it will create line segments within the tolerance that you specify here. Creates a very large code. If you have a machine that's able to execute helixes, then leave this unchecked. This is an OD thread. Our minor diameter is 0.865. It's a right-hand thread. We're going to go from top to bottom, performing a climb milling operation. I'll say OK. We'll activate backplot. Move this around a little bit, and let's take a peek. Our end mill comes down, and depending upon how many active teeth we have told it that we have will depend how much engagement there is between the tool and the material. So it moves in, helixes down, and swings around, finishes, exits, and comes up again. Okay, let's go ahead and do our internal thread now. I'll activate our thread mill. I'm going to select our top point, click OK. I'm going to use the same tool. Go to my thread milling parameter pages, 9 active teeth, clearance plane is fine, feed plane, that's okay. My top of thread in actuality starts at negative 0.750. My thread depth, if I go absolute, is going to be minus 1.375. Now, since this is a through hole, and I'm going to assume that I have clearances underneath, I'm going to increase this a little bit more just to give myself a little bit of latitude. So I'm going to give it 1 extra thread depth. So we'll put it at negative 1.5 inches. This is absolute. Now, if this was incremental, I would change this to where it would be a distance from the point that I chose, which would be negative 0.750. So I can go either way. So absolute, I'm going to leave it at negative 1.5. Thread pitch is the same. Start angle, allowance, and so on is all the same. It's an ID thread. My major diameter on this one is 1 inch. It's a right-hand thread. And if I do a machining direction of top to bottom, that's conventional milling. If I have it enter the hole and go from bottom to top, that becomes climb milling. And this would be the preferred method that I would use. I'll click OK. We'll go to backplot. Our tool comes down and helixes up and then out. Now, if you would like to see this whole operation, let's go to verify, and I'll show you what you can do. We'll select the machine group. I'm going to go to my isometric view. Let's enter verify. Since we haven't machined all of the rest of this part, what I've done is supplied you with an STL file so you can bring in a pre-shaped part. So let's go into our configure page. We're going to switch our stock from box to file. Now, along with this file, one of the files that you were able to download would have been 3421.stl. So wherever you have saved that, go find it and highlight it, say open. Let's set our tool tolerances to 1,000th and our STL tolerances to 1,000th. Check on change tool color and we'll click OK. And what you'll have now for your stock is a solid representation of the part prior to threading. Now, the first operation is going to be a slot mill that's going to come right around here and machine in a thread relief. So let's take a look at this. We're going to increase the quality. We're going to slow this down. I'll even have it show the tool holder. And let's go ahead and let it cut. Now there is our slot. And we'll stop right here. And you can see how it helixes down and comes out. Our next operation, we'll move over, down, this out, helix around, and exit our part. And you can see with the pre-cut chamfers and everything how it just funnels right on into our part. And we have our threads cut in. Now let's do the same tool paths with our single tooth thread mill. So I'm going to right click on this, drag it down, release, tell it to copy after, go into my parameters, go to the front page of it, right click, create a new tool, undefined. My custom level is going to be level 5. Now you can see the outline of my single tooth thread mill, 0.625. I'll say OK. Go to my thread mill parameters. Now for my number of active teeth, instead of 9 I'm going to say 1. Okay, this is an OD thread. Everything else stays the same. I'll accept it, regenerate it. Let's go ahead and go into backplot. And what you'll see now is our tool comes down and it helixes down as many times necessary to get the amount of thread that we need with only a single active cutting tooth. Now we can do the same thing for our internal thread as well. I'll right click, drag that one down, copy after. We'll go into our parameters, go to our front page, and we will select our tool number 3. Go to Threadmill, and now instead of 9 active teeth we have 1. Everything else is the same. I'll accept it and regenerate it. And with this tool, it'll enter down in the bottom and then work its way up. And it will helix as many times as necessary to give us the amount of thread that we want with only 1 active tooth. In this video we're going to take a look at thread milling. Now thread milling is another toolpath within the circle mill family of toolpaths, and to access it you can get to it from the toolbar right up over here. You can go up into your main menu bar and under toolpaths, down to circle paths, over and down to thread mill. I could also right click in my operations manager, mill toolpaths, drop down to circle toolpaths, over to thread mill. Now before we get into doing that, I want to take a quick look at what is included in this file. Alt-Z opens up my levels manager, and currently level number 2 is my main level. I'm going to make level 1 visible. Click OK. Alt-S unshades my part. So there's the solid part that's on there, and then you'll see some wireframe. Now the wireframe for the most part is what was used to create the solid. There's a couple other elements up there though. I've got some points which I'm going to utilize to create the tool paths, and then this inner circle right here is being used in a tool path which is already created for a slitting saw to undercut this boss that's sticking up to act as a thread relief. So let's go ahead and take a look at this tool path and verify. Go into verify. Now I'm just getting a block of material here. What I want to do is I'm going to use the solid that's on the screen. So I'm going to go into my options. For my stock shape I'm going to select solid and click on my selection button. Alt-S shades my part. I'm going to come over here and I'm going to select my solid. Click OK. And now I've got my solid part representing the stock. Keep my quality up, turn the speed down a little bit, and let's go ahead and machine this. And you'll see a slitting saw come in and undercut the post that's sticking up, and this will be my thread relief. Isometric view, exit. I'm going to go back into my levels manager, Alt-Z. I'm going to make level 3 my main level and turn off the visibility on level 2 and level 1. Click OK. Alt-1 is my top view. Now what's residing on level 3 is the geometry that is going to define my thread milling tool. Alt-C. I'm going to go back to level 2 as my main level, turn off the visibility of level 3, turn my visibility of level 1 back on. Alt-7, isometric view. Alt-S turns the shading off. I'm going to right-click in my Operations Manager, Mill Toolpaths, Circle Toolpaths, Threadmill. I'm going to zoom in, and I'm going to select this point. Click OK. If my operation is thread milling, I'm going to go to my tool page. I'm going to go into the white area of the window, right-click, and create new tool. Select Undefined, and for the profile, I'm going to toggle on Custom Level and type in Level 3, hit Enter. Now you're going to see the profile representation of the geometry that is on Level 3. This dotted line right here is how the system is going to compensate for the diameter of the tool. What's defaulting to 1 inch, that's not what's drawn on there. What's actually drawn on there would represent 0.625 diameter tool. And now you see this dotted line move to the edge of the tool. Now the other thing that I'm going to do is go to my parameters page on this, and for the tool name I'm going to type in Threadmill. Spindle speed I'm going to select 1200 RPM. Retract rate, let's do 15 inches a minute. Plunge rate, let's do 12 inches a minute. And feed rate, let's put it in at 25 inches a minute. And click OK. Go to our cut parameters. Now the tool itself has 9 active teeth on it. My pitch is 125, so I can leave that where it's at. My thread starting angle, if I wanted to orient the beginning lead of this thread, I can define it here. I don't need to do that on this part. My allowance, this can give me the ability to adjust the size of the thread itself, depending upon whether it's an internal or external thread. Taper angle, if we were doing a pipe thread. Compensation type, computer, control, wear. I'm going to go ahead and select wear. Is this an ID thread or an OD thread? Okay, well, it's outside diameter. I need to tell it what the minor diameter is. On a 1" 8 thread, my minor diameter is 0.844. Right or left-hand thread? Well, this is a right-hand thread, and I want to climb mill it, so I'm going to go from top to bottom. Continue to lead in, lead out. External thread, I've got plenty of room. I'm going to do 150 thousandths on that. I don't want to start at the center. I'm going to give it an extra line length, say 50 thousandths. I'll need that straight line move so that it could turn cutter comp on. Perpendicular entry, I don't need that. Helical entry at the top of threads, yes. At the bottom of the threads for the exit, yes. Linearize helixes. This you would toggle on if you were dealing with a machine that couldn't process helical moves. By toggling this, you can define a tolerance and it'll start to create a whole series of linear moves for that type of machine to process. I can access multipass. I'll activate it. I'm going to go ahead and let's give it 3 roughing passes of 0.035. 1 finish pass, and we'll make that 8 thousandths. I can specify spring passes if I desired. I can override the feed rate. My linking parameter. I'm going to go ahead and right-click in this field for my thread depth, Z, coordinate of a point. Brings me out to my graphics area, and I'm going to go ahead and select the center of this arc. Now you see it automatically inputs a depth of -750. Now I don't want to take a chance of the tip of the tool touching the top face of my part. So I'm going to shorten this up just a little bit. I'm going to make it like 745. The top of the thread is at 0. Feed plane, 100 thousandths above that. Clearance plane, let's make this 1/2 inch. I can turn on coolant and so on. I'm going to go ahead and accept this. I'm going to select both my operations and go into verify. We'll have it come and machine the thread relief and now the thread milling. And it's taking its multiple passes, getting deeper each time. Right click, dynamic rotation. I'm going to pick the center of this and move it around. You'll see I've got the threads cut. Now we're going to create the internal Threadmill toolpath. Now I'm going to make sure that my second operation is the only one that is checked. I'm going to right-click, drag, release, copy after. Now I'm going to need to switch points because both of these operations are being generated by this point here. Left-click on the geometry portion of my operation, and that'll bring me to my drill point manager. Right-click on the point in my manager, delete point, come to my graphics area and pick the point to delete. In the manager, right-click again, add a point, come to the graphics area. I'm going to select this point now, click OK, and click OK. Now let's go back into our parameters. My cutting tool is going to be the same. For the cut parameters, same information on top, with the exception that we're going for an ID thread now. And this will have a major diameter of 1 inch. Still a right-handed thread. I'm going to go from bottom to top so that it's climb milling. For the lead in, lead out, I'm going to get a little more conservative and change this to 100 thousandths. Straight line, let's make this about 20 thousandths because I'll need that if I'm using cutter comp. Multi-passes, make this 2 at 25 thousandths. And we'll leave the finish pass the same. The linking parameters. Okay, I'm going to switch over to absolute. Right-click, z-coordinate of a point, and I'm going to pick that point. Right-click in the top of thread field, z-coordinate of a point, pick this point. For my feed plane, I'm just going to go ahead and I'm going to type in a negative 0.5. And my clearance plane, I'll leave that as it stands. Click OK and regenerate. Now I'm going to go ahead and verify all of these. Click on my toolpath group, go to verify, and let's see what we got. Does the undercut. Mills the threads on the outside. Should be the finish pass. Comes inside. And there we go. Now just to take a look at this, I'm going to go ahead and split my verify results. I'm going to click on this button. I'm going to pick a spot that will act as a dividing line. I'm going to pick right over here and then come back behind it and select which side I want to keep. I could either be on this side or this side. I'm going to pick this. I'm going to right-click, dynamic rotation. I'm going to catch the center point of this circle and then just spin it around. And you'll see that we have internal threads now. I'm going to exit, Alt-7, isometric view, Alt-Z opens up my levels manager. Now on level 5, I'm going to turn off my toolpath visibility. Alt-1, top view. On level 5, I have the profile of another tool drawn. Now this would be in the instance where you don't have a thread mill, but you've got a boring bar that you could regrind. And you can grind in your 60-degree included angle, put the flat at the tip of it, and draw it out. And you could thread mill using this. The only difference between the thread milling tool that I was using in these operations and what this would do is the number of active teeth. The previous one had 9 active teeth. This one only has 1. So once again, I'm going to make sure that this operation is the only one that is checked. Right-click, drag, release, copy after. Go into my parameters. Go into my tool page. Right-click, create new tool. Undefined. Custom level. Level 5. And now you'll see the profile of this tool. The diameter is going to be the same, 0.625. In here, we're going to do the same thing. Mill 2. Spindle speed, we'll use 1200. Retract rate, 15. Plunge rate, 12. Feed rate, 25. Now it's telling me that there's a similar tool. I do want to add another one, so I'm going to say yes. Go into my cut parameters, active teeth, 1. The thread pitch, the same. ID thread, major diameter, right hand, bottom to top, lead in, lead out. All of this I'm going to keep the same. The only difference is my active number of teeth. Click OK. Alt-Z. I'm going to turn off level 5. Click OK. Alt-7. Regenerate. And let's just do this one toolpath. Go to Verify. Comes down and works its way out. And there you have it.